Hello, everybody. My name is Amirreza Zarnaksh. I'm a PhD student working at KU Eco Hydraulics Lab, and today I'm going to present our analysis of urbanization effects on solute delivery to streams. We know increasing freshwater salinity has become a big problem in many parts of the United States and also Kansas, as it can result in issues such as degradation of drinking water and also biodiversity reduction. We also know that urbanization is known as one of the major causes of this issue because it changes the hydrologic pathways of solute delivery to streams, and also because it adds new sources, including wastewater treatment facility, to our system. So in this study, we have used high frequency 15-minute specific conductance data, which works as a proxy for freshwater salinity from 2002 to 2014 across Johnson County to understand how urbanization affects solute delivery to streams. So here you can see a map of our studied watersheds. We have Kill Creek, Cedar Creek, Mill Creek, Indian Creek, and Blue River, which are very different in terms of land use. So urbanization level changes from 16.7% in Kill Creek up to 98.3% in Indian Creek. The first method that we have used is hysteresis analysis, and hysteresis is the changing relationship between specific conductance and discharge. So for each storm event, we can have one of these four different patterns, depending on the concentration of solutes transported to the streams. We can have like a flushing pattern or a diluting pattern. Also, depending on the location of the sources, whether they are proximal or they are distal, the peak of the solute concentrations can happen before or after the discharge peak. So we identified 828 different storm events, and we classified those into one of these four different categories using flushing index and hysteresis index, which are indices that are developed to make this classification easier. To quantify the contribution of base flow versus runoff, we have used the two-component hydrograph separation method. So we are assuming that the solutes are coming from one of these two different sources, the new water or runoff and the old water or base flow, and solving this system of equation, we can quantify the contribution of base flow or old water with high specific conductance compared to runoff. So here we can see the results of our hysteresis analysis. Each point here represents a storm event, and we can see most of the storm events are in quadrant A, indicating they have a diluting pattern with proximal sources that are rapidly depleted. This is a good news in terms of freshwater salinization. However, the alarming point is that in Indian Creek, the most urban watershed, the blue point, which is the average of all storm events during winter, is very close to quadrant B, which has a flushing pattern with solutes that are not depleted during the storm event. So we can say that basically the winter storm events are more likely to increase salinity of streams in urban watersheds because of road salt application and de-icing agents. So looking at the results of our hydrograph separation analysis, 2 points seem to be interesting. The first one is that in all watersheds, base flow has a higher contribution to storm flow compared to runoff. And the second point is that the new water or runoff contribution lag the increase in discharge, indicating the old water with high contribution of solutes flushes first. This can again shows the significance of proximal sources in our system. So the final conclusion of our work is that the primary source of solutes in Johnson County's streams is located near the stream channel and is rapidly mobilized and depleted during the storm events. However, this is not the case for urban watersheds during winter season. Thank you very much for your attention.